Once we've seen inference for one proportion and inference for two proportions, sometimes the two tend to get a little bit mixed up with one another. And what we want to think about is whether we're talking about two proportions that come from the same group or two proportions that come from two groups. Because oftentimes it is the case that we have more than one proportion that might be related to our question. In this first drawing here, where both proportions come from the same group, we cannot use these inference techniques for P1 minus P2. We would have to somehow rephrase this question as just one proportion instead. And there's always a way to do that, right? If you're interested in saying, is the proportion of voters who are going to vote for the Democratic candidate higher than the proportion of voters who are going to vote for the Republican candidate, that is comparing two proportions in the same group. We do not use a statement of two proportions there because all of the calculations that we've seen assume that these are independent and that they come from different groups. Incidentally, the way that you would handle that particular situation I was just talking about is you would just eliminate all of the third party or unaffiliated candidates and then ask the question of whether one of those is greater than 50%, right? So you can rephrase it as a single proportion. In the two groups, this is really the model for P1 minus P2. So let's look at a couple of descriptions here and classify them as one group or two groups. Compare the proportion of registered voters, so number one, in the Democratic Party who are in favor of single-payer health care to the proportion of registered voters in the Republican Party who are in favor of single-payer health care. So the proportions we're calculating are from registered voters in the Democratic Party and from registered voters in the Republican Party. Those form our two groups. So we have two groups here, our Dems and our Republicans, right? And in both cases, what we're calculating a proportion of is that single-payer health care. So this is two groups, and we would use P1 minus P2 type of inference to address this question. Looking at this second example, among all voters registered in the Democratic Party, compare the proportions of those in favor of single-payer health care to the proportion not in favor. So all voters registered in the Democratic Party, and the two proportions I'm comparing are in favor and not in favor. Really, this is this model here, right? The bucket is Dems, and the two proportions are in favor and not in favor. So clearly what we need to do instead of setting this up as two proportions is to eliminate all the ones who maybe didn't have an opinion. If there was an abstention option, eliminate all of those from the sample and just ask whether one of these is greater than 50%, right? So we would just use inference for one proportion. Because this is one group. Now, compare the proportion of pet owners who shop online for their pet food to the proportion of pet owners who shop in brick and mortar stores for their pet food. We've got of pet owners and of pet owners. we've got, you guessed it, one group. The bucket in this case is pet owners. And the proportions are online and in store. Again, we cannot use P1 minus P2 type of inference to ask a question like this. We would have to rephrase it as one proportion, eliminating everybody who, I don't know, makes their own pet food or somehow didn't fall into one of these two categories, and just ask if one of these is greater than 50% instead. So this is one group, no using P1 minus P2, not allowed. Last one, compare the proportion of pet owners in Austin who shop online for their pet food to the proportion of pet owners in New York who shop online for their pet food. We can really see the difference here, right? Two proportions. We've got Austin, ATX, and we've got New York. And both of these are comparing shopping online. So another thing that we can see is true about comparing two proportions is that we're comparing the same thing from each bucket, if it makes sense to compare two proportions. We're not comparing two different things from one bucket, right? So these are the kinds of situations where we do use this new procedure for two proportions. Number 4 and number 1. We could see in both number 2 and number 3 that there was a way to rephrase that as a question involving one proportion, and that would be the correct way to do it because it's not two independent proportions. One of those can't get bigger without the other one getting compensatingly smaller. Now I will caution that it's a little bit easier to recognize these when this is the question than it is to recognize these when you are setting up a hypothesis test. It's fairly common for a question that really involves one proportion to be misinterpreted as a question that might involve two proportions, or even for the way the proportions are defined to not be totally consistent with this. So it's a good picture to have in the back of your mind as you're setting up a a hypothesis test for two proportions. Maybe picture the buckets in the back of your head too, and make sure that your two proportions are what they should be for this picture to make sense. Just to put this into context of an example that we've seen, here are ways of defining PS and PN. One of these is correct and one of these is incorrect from our fertility and smoking example. The first one says P sub S is the proportion of successful pregnancies among smoking women, and the second one says P sub N is the proportion of unsuccessful pregnancies among smoking women. The second pair, proportion of successful pregnancies among smoking women, and proportion of successful pregnancies among non-smoking women. Think for a moment about which pair you think is correct. And I will now say it is the second pair that is correct for using PS minus PN. These are two independent parameters. If we put this in the context of what we were just talking about, notice that the first pair, both of them say among smoking women. So this is one group. And also notice that the things we're comparing are not the same, right? Successful pregnancies, unsuccessful pregnancies. We're supposed to be comparing two proportions that are really the same measure of success, but from two different groups. Whereas if we put this second pair of hypotheses, or sorry, these aren't hypotheses, these are parameter definitions, to the same test, we see among smoking women, among non-smoking women. So first of all, we see this as two groups. Then we also see that we are comparing the same thing. Successful pregnancies get compared to successful pregnancies. So this is the correct parameter definition for the problem that we were looking at with fertility and smoking.